Hey guys, welcome back to a C devlog. In this episode, we're going to be discussing arrays in my language. So I've been thinking about arrays a lot and for a long time. And what I've kind of determined is I think I need to store the size of the array at runtime, which I don't really love doing because of course that's extra bytes that every single array is going to need to have. So I'm adding a runtime cost. But it's not necessarily adding a runtime cost, because in C, when you use like any standard library function that takes arrays, either there's two outcomes usually. It's either one, you have to pass in the size separately anyway, in which case I might be using a few extra bytes because I have to store it in the largest possible size. So that's not perfect. Or two, they don't take the size, and if the array is like too small, it will just either crash or have a horrible security issue. So I think this is going to be the best. I was considering making array sizes need to be sort of like compile time constant, but that's kind of a pain, especially to type and to use. And like it's still not useful because then I would have to make indexing also like compile time constants, and that would literally mean like, well, I guess if you had like a for loop when you have this, that would mean your condition has to be a compile time constant as well. Like it would just be a huge pain. It would be really messy. So this way, overall, it's not too bad. So if I show you like the type, essentially it's just a size t to hold the size and a void pointer to some array, essentially. And then of course I have a nullable version of this. Something else I realized, I keep embedded is always in the back of my mind because that's kind of a huge use of C. Because if you're using embedded, you kind of should be using C a lot of the time. And so I don't want to add a lot of runtime costs because on embedded systems, those add up very quickly. But I guess hypothetically, I don't know this for a fact because I don't know much about embedded systems, but I suppose I'm worried that like, okay, a size T, that's 8 bytes per every single array. But actually, that's only 8 bytes on a 64-bit system. Hypothetically, if I were guessing, an embedded system would frequently be less than 64 bits. It might be like a 32-bit, 16, 8-bit type system, which I suppose then means at least the size T is going to be smaller, so it's not as big of a deal. But still, I just think this is like a compromise I have to make, and I think it's overall a good decision. Don't look too much at the actual resulting code. I basically just got my compiler to recognize declarations, but it's not currently doing all the checks. So for example, you can see one of the hard things about arrays, and I'm using this sort of Python-like list syntax, which I kind of like, I have to deduce the types of the whole array. Like this thing is supposed to be an array of complex numbers, and why is that? Well, because we have an imaginary here and we have a real here. Technically, these are ints, not reals, but ints are real numbers, like mathematically. So once it sees the I, it should figure out, okay, this is supposed to be an imaginary list, and then the next item is not imaginary, so it should figure out, okay, this is actually a complex, and it has to do that for every single element. But that also adds a lot of issues. Because, for instance, if you remember back to the last episode where there's a lot of casting of nullables, if these were nullable values, if these were like a nullable int and a nullable imaginary, once it figures out that this is an array of nullable complex numbers, it will have to cast each element individually to a nullable complex. So that's going to be a pain. And that doesn't even mention arrays of arrays, which is going to be even more so. I think what I have to do, my plan for that is basically figure out the type of the array first, keep these values, and then at the end cast it. Because if you cast it each step, that's just going to be too messy. So what I need to do is just have these independently, figure out the overall type, and then cast them to that type, which shouldn't be too bad. Now, while arrays don't have compile time sizes, I am having this notation mean something. So you notice this one, it infers that this should technically be an array of type complex. And this declaration would work too, but so would this one. The issue is, okay, so there's a reason for this, right? A lot of languages allow you to specify size when you're declaring an array, and why is that? Well, this is a declaration with no type, or with no expression. So what that means is, I don't want it to just do this. I want it to actually allocate the array here, so that when I do the assignment, it can just fill it. You know what I mean? So, I guess, do I want that though? Because now that I think about it, in other languages, you can sort of use uninitialized data, so like in C it doesn't really matter, but here, hypothetically, if you allocated this, you could do something like this. You could assign each individual thing, right? That's interesting. But I wouldn't allow this because Y hasn't been initialized. But this is like itself an initializer. Oh, arrays are such a pain because of this. Before, you just have identifiers on the left-hand side, just like variables. But now, anytime I'm doing like an assignment, you can also use like indices and stuff. That's going to be... It shouldn't be too bad, but it's not going to be great. So currently I'm allowing you to specify size, so that when you do something like this, it can allocate the array first. And then, of course, I'm allowing this as well, because if you can do this, you should be able to do this too. Which now leads me into an issue. And that issue is, what if these numbers don't agree? Well, in this case, it's not too big of a deal, because this is 3. But what if I wrote 3 as 5 minus 2? That's allowed. That's a compile time expression, you know? Like, I know that at compile time, or at least the C compiler will. And I could do something in C where I do like a static assert, but I'd rather all my like error checking, or as much error checking as possible, be done by me, not C. So what this means is, I'm going to have to essentially add an interpreter into my transpiler, so that anytime there's a compile time constant, I should know what this is. I should know that this resolves to 3, essentially, at compile time. That way I can compare, okay, this is 3, that's fine. And I'm not sure, so if I think if you do this, this shouldn't be allowed, this assignment. But I think if you did this, it should be allowed, and it should just take the first 2, but it should throw a warning and say it's not used. But I think it should be allowed. When it comes to this, though, I don't think that should be allowed. Because you'd assign the first 3, but not the rest. Which overall, like, isn't too big of a deal. But with the way that I'm handling things and not being able to use uninitialized data and stuff, and you have to initialize everything at once, yeah, I don't know how I'm going to handle that yet. I haven't really decided. So, I guess, honestly, that's kind of the state of things so far. If I look at my grammar, it's not too different. Yeah, let's see, I'm just trying to think now, is there anything else interesting to even show? Because that's kind of it. So I construct the primary expressions. Yeah, so for example here, I'm storing the array size as part of the type, but I have to actually parse what that type is, or what that size is at compile time, like I described before. So in these transpiles, that means every expression, all of these expressions, any additive one, whatever, if these things are constants, it should keep track of the value in my t expressions, which is like the output line, which you can kind of see here, for example. When I'm transpiling an additive expression, you transpile the left, you give the operator, which is a plus or minus, and you transpile the right. And this line is essentially a C expression, so it's going to like, if you said X, I guess I can show, sort of. Actually, I kind of can show exactly. I think it's going to complain, though. Let me declare these for X. And I also have to initialize them. And then if I show like the resulting expression. It's just this, you see. That's exactly what's in here. It's your left, your operator, and your right outputted from this. So I'm going to actually have to come in here and I have to keep track of that value at compile time, probably, if I'm going to keep doing things the way that I am. Which I think is the right way to do things. Also, doing things that way, where I have like a value at compile time, I might be able to do some optimizations. Like, something that's obvious is, suppose these are vals instead of variables, so they are just compile time constants. If I did x plus y, the result of this expression could just be 0. Like, I don't even have to do the x plus y thing. Like, I don't think it matters that I do, because the C compiler is going, or maybe even the C preprocessor, but well, literally, right? Like, the preprocessor is going to substitute in 0 and 0 here, and then the compiler is going to see 0 plus 0 and optimize that away, obviously. So I could do that, or I could just let the C compiler do it and keep the source code more readable. So I'm not sure. But when it comes to maybe nullable casting, maybe I could optimize that by keeping track of the same thing. Like, but that's the issue, right? When you cast from like one thing to another, sometimes that will change the value. So if I create a nullable z, I'm very creative with these names, and it's a nullable int. Actually, it should be a nullable real, so that it's floating, like pi. If I cast this to a nullable int, and then I cast it back to a nullable real, that is not the same as casting it simply to a real, because that would do nothing. But once you cast it to an int, you truncate it and you just take the 3, which you then cast back to a real. So I can't exactly optimize that away, because let's see, what does it even look like now? What? I didn't save it. That explains it. Because right now it looks like this, which is a huge mess. So even the declaration is enormous, but you see it says it's not null. It gives its value, and then I have to construct a nullable real. Ignore the error. That's just because we're doing this in the global namespace or whatever, and it has to be like inside of a function to actually make sense. But so you see we're making a nullable real, which is the result of we construct then a nullable int here. That's the inside. We check if that's null, and the nullable int is of course the cast of z to the int, which is just annoying. And then we copy the exact same thing twice, and we take the value instead of the is null portion. And I think the C compiler optimizes this away, so I'm not too concerned. But it's certainly annoying to look at. One thing I could maybe do is I could just make a macro in C as part of my standard, and it would maybe simplify the way it looks. So like, if I made like a cast2 macro, and what would I need? I need like the... It doesn't matter what the thing you're casting is, but you need like the nullable type and a type, and a value, essentially, and it would have to be something like you're returning a nullable type of this thing, which is the value.isNull, followed by you have to cast the value. And obviously I'm not doing this perfectly. I think you might want extra parentheses around these arguments. Although I guess it doesn't matter because it's not a user inputting them, it's me. It's going to be my compiler inputting, so it's never going to be like something that would have to worry about that. But cast the value now. So you'll see like it's still referencing the value twice, which is exactly the same as this, but at least this way it might be more readable. In fact, it should be a lot more readable. I think this will probably be worth doing. Like, look at that. That's like not too bad, right? And then if I replace this, in fact, let me just rewrite it myself. I'm not going to end up calling it cast2 because I'd have to do something better than that. But let's see if we replace this with cast2, we're casting this to a nullable real. The base type... Actually, what I could do... I could be even more clever than this. I know it's going to be a nullable, right? So what I can do is... What I can do is I could say C type nullable. And then I can add the type character in, like this, I think. And then with this type, I'm pretty sure that's how you append tokens in the preprocessor. So instead of passing in both, the first argument can just be real. And then the second argument can be just C var Z. Except actually, it's going to be something else. It's going to be cast to... first I cast it to an int and then C var Z. So this whole line 6 could be written as this. And it would essentially be the exact same thing. I think it would be identical. Because it would just replace that in. I would give it the type, and that's not a big deal. And while it still will do the same thing, while it will still produce the same code, it's going to be significantly more readable here, and it's easier for me to debug as well. So that's probably worth me doing. I might have to add some like parentheses around this, for example, just to be safe. And the casting should happen after the accessing. The accessing is a higher priority. And the macro is obviously going to be even higher. That's still a postfix thing. So yeah, I think this will work. But yeah, that's, I guess I shouldn't just keep going with this unless... If you're interested in this kind of thing where I'm like live designing something, let me know. But that's not necessarily what the series is, but I guess the series is whatever I'd like it to be and whatever you guys are interested in. So I think I'm going to actually implement something like this. That's probably going to make things a lot easier. Hey guys, this is me from the future just adding a little bit extra to this devlog. So I think I'm going to remove imaginary types. The reason I added an imaginary type is because C doesn't support one. They support complex numbers in the standard, but only certain compilers actually support an imaginary type, so I figure, well, it makes sense, right? Because the issue with a complex number in C is that it's essentially just two floats or two doubles or two long doubles back to back, so it's twice the memory. One double is for the real part, one double is for the imaginary part. But if you have a number that only is imaginary, why should you have to spend twice the memory to represent it? The other alternative is you could store your imaginary as a float, for example, but then the like assignment won't make sense. Instead of saying like I guess if I go into my header file for now, it doesn't really matter. If you say something like double x is equal to like 2i, in this case it's j because C is stupid, and engineers and all that, this isn't going to like make any sense. You'd have to do the imaginary on this, which of course, as you can see, is an issue because when your variables are static, you can't use cimag. So the other thing you'd have to do if you want it to be compile time constant is you have to divide out the I. But like, how are you supposed to know that x is supposed to have a 2i here, for example? Like, what you could do is you could name it imaginary and you could just set it to 2, but like xi or something, and like, it's stupid. It's really stupid, but the people who made C decided that they shouldn't support imaginaries, so unfortunately that makes my job way too hard because, for example, as you see, I'm starting to implement that macro I was talking about, but I figured I realized I had to have a value in here because when you're casting relative to an imaginary type, you can't just do a normal cast. You have to actually do certain things. So if you're casting from imaginary to imaginary, you're actually just casting the complex expression. If you're casting to something that isn't complex, it has to return 0 because you're taking the imaginary part, you're taking the real part of an imaginary, but you have to do that at compile time, so you can't use C real. You have to just cast 0. And then if you're doing the other way, which is even worse, you have to subtract off the like real component to get the imaginary from something that isn't. Like, it's such a pain. But oh yeah, if you're casting from complex to imaginary, you have to do this. You're just taking the complex and removing the real part of it. But all of this is just such a pain, and I also have to add so many other things. So if I go into, like, for example, additive expressions again, I have to add this line where, well, if one of them is real and one of them is imaginary, then I have to actually cast it to a complex number. And in multiplicative, oh, it's even worse in the remainder. Remainders are already kind of a pain, but you see, so if it's complex and real, it's not too bad, but then there's a bunch of these imaginary ones that you see I have to do. All this logic is just for imaginary types. Basically, I had to actually figure it out, and I'm kind of proud of that, but if you have, like, imaginary on one side and real on the other, then you figure out, let's see, if you're taking the remainder of something real with an imaginary mod, the result is going to be real. And if you take imaginary with a real mod, it's going to be imaginary, and otherwise it's also going to be imaginary, even if they're both imaginary, I think. But, like, it's just a pain, because the expressions are actually complex, but the storage variable type is going to be real. So I have to do so many conversions in everything. And so it just makes everything so complex to support it, when really, nobody really even uses imaginaries in coding at all. Like, there's certainly times when you would. But using complex numbers in programming, to me, is pretty rare, unless you're doing something very specified. But using imaginaries alone is even more rare. So I don't even think it's worth my time to support this and make all of my codes so much worse. So I think I'm going to just not support it anymore. Another justification for not supporting it is, suppose you have, like, x is equal to 2. If you say, like, x times equals 5, that's fine, because the integers are closed under multiplication. So 2 times 5 is always going to be an integer. Now, in programming, that's not exactly the case, because if this is, like, a number that's at the edge of what an integer can support and we double it, then it might not fit into our x, which isn't great. But if x is 2i, and we multiply equals it by 1i, this x becomes 0, because imaginaries are not closed under multiplication, which is kind of stupid. You know what I mean? Like, it's kind of dumb that you can even have that situation occur. Whereas if I interpret this as complex instead of imaginary, it makes sense. You'll actually get your, like, -2 instead of just, well, the imaginary part of -2 is 0. So I think I'm going to drop support for imaginary numbers, at least for now. I looked, and some compilers support imaginary numbers, but not all of them, and I can't get GCC to, and it's just a nightmare. So I'm just going to get rid of those, simplify down my code, make it better, and hopefully that's all right. Now, I think I'm probably going to edit this and put it back into the video before the outro, so back to past me. Haha, gotcha! It's actually future me again, this time from the future. So, I've made some decisions on the arrays already. I'm not going to allow you to specify size at all, because I'm not going to let you... If you say, for instance, what like var x of type array of int, this expression where there's no value, it's not going to initialize anything. It's just going to, well, it's going to initialize the array struct, but once you actually assign, like, x is blah blah blah, that's where it's going to allocate the array. And I think I did find a good way to do this, because I didn't realize that the syntax was a thing. So I forget this, like, specific, what is specifically, it's called the compound literal. Yeah, the compound literal initializer list syntax. This is, like, the solution to that casting problem I was talking about, and it's going to just, oh my goodness, look at this. So you can make this initializer list, which is just your items, right? It doesn't matter what they are. you can just then use this syntax to essentially cast all of them, and it just works. Like, okay, now I do still have to be careful about my nullables, because those obviously won't work with this, but for normal values, that just like completely solves it for me. That's so good. And look how easy this is, because this will be like the assignment. I can just, suppose I construct my array here real fast. It's a size t size, and like a void pointer data. And then, hypothetically, what I could do is I could have my initialization for like my array R, just like that. Although I suppose I should initialize it to, this is 4 items and null. But what I could do is I could come in here and I could say, okay, r.data is equal to this thing, because this literally allocates it for me. I don't have to construct the array and then assign it, I don't think. And then I can come in here and say r.size, and I can print them out. Yes, I have to now... I do, of course, have to do this, plus before I access it, I will have to cast it to an int pointer, but that's okay. And it works. So that's the assignment. This would be like the initialization, actually. It'd be something more like, well, it would be like nothing. And then it would be like r.size is equal to 4 here. And this would be the actual assignment. And this would be reassignments as well. So every time you reassign, you'd make a new array, which that's kind of messy, but that's what you're doing when you reassign an array. If you want to change the elements, you can just assign to the access instead. So you could say like this is equal to that, and that would be different. But so I think this is how things are going to go. You're not going to specify size. Size will be like a runtime thing, but it's actually more of a compile, like it's still a compile time thing, because basically the size will be inferred based on your initializer list. So when you initialize an array, you would just give in a list. And I can add different syntaxes to make that nicer, sort of like how in Python you could say this, which is directly equivalent to like 5 of these. You get the point? And there's other syntaxes that help with that. Like this, that like solves so many of my problems. Okay, I think now I'm going to go back to past me. But I think that's going to be it for this little devlog. Shorter than the other ones at least. And I'll let you guys know what I end up deciding to do with all this, and if I make everything work properly. And I will see you guys in the next devlog.